In this video, we will see how to use the plot command, figure plot command, and subplot command in MATLAB. So this is what we will achieve in task 1. Task 1 says plot the graphs corresponding to the following equations using MATLAB. Plot the graphs individually, then combine them in a subplot. And we have the parameters such as range, sampling time, x-axis and y-axis limits, and also we have the signals that we want to plot. So let me go to MATLAB. And first things first, you have to go to your correct working directory. If you have not created a working directory, you can refer the previous video and create a working directory for this laboratory session. Then in the current folder, I will create a new script. Again, remember we are using script, not live script. I will create a new script for task 1 and then I will open it. Now, at the very beginning, I personally like to use 3 commands. Those commands are clear all, close all, and CLC. Now, this is not compulsory to use, and some code such as clear all, actually MATLAB recommends you to not use it. But this is what this commands does. So clear all will clear all of the variables that are saved in the workspace. Close all closes all of the other windows that are opened in MATLAB aside from the main MATLAB window. And CLC clears the command window history. MATLAB suggests not to use clear all command since it removes the cache as well, and it will take more processing power when we are running the code every single time. However, you can omit this, but it is a good practice which I like to use to avoid any confusions with regards to the variables or the command history and etc. Now, firstly, when we want to plot a graph, we want to define the x-axis or our independent variable. So I will label my independent variable as x. So you can say x equals. Then there are 3 values which you should enter. The 3 values are the starting value, the sampling time or the increment, and the finishing value. So in here we have the starting value as 0 and we have the finishing value as 20 and the sampling time or the increment of 0.001. In MATLAB, I can just separate these out as 0, my starting time. You can put a colon to actually separate it. Then I will say my increment 0.001, again colon, my finishing time, which is 20. Generally, when we are coding, it is a good practice to actually put a semicolon after each line. That is being practiced in all the other forms of coding as well. In MATLAB, if you do not include a semicolon at the end of each line, it doesn't affect your actual coding. In MATLAB, what this semicolon does is whether to display this function or whether to display what is being created in variable x in the command window. So if you put a semicolon, nothing will show up in the command window. But if you omit the semicolon, then in the command window you will have basically a matrix of all the values that are stored in variable x, and that can get the command window very complicated and messy, and we can't actually it's very difficult then to use the command window for something that we actually need. So because of that, I actually like to use a semicolon at the end of each code line, and also only if necessary we can omit the semicolon. Then next we need to define our graph equation. So part A says my graph equation is y equals x. So here I will say y equals x, and this is the graph. And then first we will look at the plot command, how to plot a graph in MATLAB. So plotting a graph is very easy. The command is plot, and then you can put brackets. You can put your independent variable, which is x in this case, and our dependent variable, which is y. So this command will actually plot the graph. And this is not complete because the task is telling something else as well. We need to limit the x-axis from 0 to 10 and limit the y-axis from 0 to 40. Now, why we should use this limit command? It's not compulsory to use the limit command all the time, but when we want to only focus on a specific range of x or y values in a graph, we can actually limit the x-axis and y-axis, so that will gives us more flexibility to actually focus on the part that we require. So here we will practice that as well. So limiting the x-axis and y-axis requires two codes. So it's called xlim and ylim. So I will first start with the x-axis. The command is xlim. Then you have to put two brackets. Then inside you need to put two square brackets as well. Then you can say your limits. My first limit is 0, second limit is 10. So I will say 0 and 10. You can separate it with a space. Same thing you can use for ylim as well. Ylim, it's from 0 to 40. So I can say this is starting from 0 and ending at 40. Again put a semicolon, and this is done. For task 1 part A, we have successfully plotted y equals x. So you can save it using Control S or press the save icon, and you can run it. So to run it, you can actually press F5. When you run it, it will automatically save as well. So I will click the run button, and it will run the command, and it will produce the graph. So this is the graph of y equals x. Obviously the scaling is a bit out of shape, but that is because we use the x-axis and y-axis limit. So if I want to actually temporarily remove these two limits, because let's say okay, I want to observe the full axis of the graph, so I can actually, without deleting it, I can comment this line out. To commenting out means you are having the line but it is not being executed. So you can actually use the percentage symbol in front of the coding line, and then you can see the color change to green, and this means we are not using this code line. We are not executing these two lines of code, and I can run it, and then this is the graph of y equals x without any x or y axis limits. Right, I will remove this because there are some other parts in this activity, which is to plot three other graphs. So y equals 2x, y equals 4x squared, and y equals 6x plus 4. Now we want to plot these graphs individually. So what is expected in this task is to actually obtain four separate figure windows. Four separate windows for part A, part B, part C, and part D. But if you look at this question very carefully, the range of x doesn't change from part to part. So that means we can use one x, right? One definition for our independent variable. However, the y actually changes from part to part. That means in our code we had y here, and when we want to plot the next graph, we can't have y because it will override. So I will change this y to maybe y1, and if you change in one place, you have to change it in the other place as well. So okay, y1. Right, next we need to plot the graphs for the other three equations. Now instead of writing it all over, I will just copy this three more times and only change this equation. Now I don't need x because x is already defined, so I will remove this x, and here I have y1, here I will say y2, and you need to change what is in the plot command as well, and this is y3, and lastly we have y4. Next, I will actually write the equation. So my y2 is 2x. So I will say 2 times x. So this is y2. Then my y3 is 4x squared. Now this is very important when having squares. Right? When having squares or anything exponential in MATLAB, this is the way to properly write it in the command in the editor. So 4, right, my function is 4x squared, so I will say 4 multiplied by x squared. So squared, if you just put this symbol, right, to the power symbol, it will produce an error because MATLAB does not recognize this as a exponential. So, oh, to the power. Therefore, you need to always put a period or a full stop before this power symbol when you want to indicate that this is to the power 2 or to the power n. So without this it will not work and it will produce an error when you execute it. So now I have 4x to the power 2. Then lastly I have 6x plus 4. So 6 times x plus 4. Now I have 4 different equations. All those 4 equations has only one independent variable. The only difference is the uh, y, or the dependent variable. Now when I execute this, I only get one graph. Right? When I execute it, I only get one graph. But the task says I need to obtain 4 graphs. The reason is I am using this plot command for each and every equation. And that will not work because plot command is just there to plot one graph. MATLAB doesn't know that we need to plot multiple graphs. So the way to plot multiple graphs or obtain multiple windows of graphs in MATLAB is to actually use another command called figure plot. So you can, there are two ways that you can have it. You can either use figure comma plot, you can type like this, or before the plot command you can have figure, right? This means I want this equation to be in a single figure or a single window. So instead of having two separate lines, I will just say figure comma plot because in one line it is easy, and the others also I will change it. Now I will execute the code. Now when I execute the code, I have obtained 4 different windows. And these are the 4 different graphs that we plotted for our 4 different equations. And this is one part of task 1. Now I will close these figures again because there is another section. It says combine all 4 graphs into something called a subplot. Subplot is where you have one window, and inside that window you have that window is separated to display different set of axes. It's not a graph where you have multiple lines in one axis. It is actually a separate graph or a separate window where inside you will have multiple axes, right? So the command is very simple. The command is called subplot. Now here, instead of deleting it, I will actually comment this figure plot because I might need it in the future. Subplot command is very simple. It is subplot. This is the subplot command. So inside the subplot command, you actually have 3 values. So those 3 values are M, N, and P. It says in the suggestions as well. So M stands for the number of rows. How many rows of axes do we want? Then N stands for how many columns, and P stands for the position of this specific graph in our subplot. So since I have four separate equations to be plotted, I will have a grid of 2 by 2. That means 2 rows and 2 columns. So in combined, I will have 4 axes. So I will say 2 rows and 2 columns, and my first graph I will plot it in the first position. That means first row, first column. And after using the subplot command, you should actually use the plot command as well. Otherwise, subplot is just letting MATLAB know that this figure should be plotted in a subplot with a grid of 2 columns and 2 rows and in the first position. But to what to plot it there, we should actually tell. So that is why we are using the plot command after that. So I will say plot x, y, 1. And similarly for y2 also, I will use a subplot command. Again, 2 rows and 2 columns. That does not change, but the only change here is the position. So instead of having it in first position, I will have it in the second position. Similarly, I will follow that for equations number 3 and number 4. And the only change in the subplot command is the position. Now this is the third one. Now I have successfully used the subplot command for all the 4 equations. Next I will execute, and I'm getting a small error. It says line 22. Okay, I have put a colon instead of a semicolon. So this is my subplot. So as you can see, this is only one single window, but inside this window I have 4 graphs. That means in 4 different axes. That means this figure is divided into 2 by 2 grid, and that is our subplot. So this is how you can use the plot command, the figure plot command, and the subplot command in MATLAB to plot graphs of different nature. In next video, we will take a look at how to plot the graphs in a single axis, how to plot multiple graphs in a single axis, as well as we will talk more about plotting sinusoidal functions as well.